is that there is a distinctive plane to the solar system. Copernicus had essentially proposed this, but Newton showed in detail how it worked. The orbits of the planets circle the sun, all of them very close to the ecliptic plane, also called the zodiacal plane, because the constellations of the zodiac are arrayed around this plane. And that's why the planets and the sun and the moon apparently move through the zodiac. Why is everything so regular? Newton asked. Why are all the planets in the same plane? Why do they all go around the sun in the same direction? It's not that Mercury goes around one way while Venus goes around in another way. All of the planets go around in the same sense. And, as far as he knew then, they all rotated in the same sense. The planets had something astonishingly regular about them. On the other hand, the comets that were known in his day were helter-skelter. Their orbits were at every possible angle to the ecliptic plane. Some went around in the direct sense, some went around in the retrograde sense, and they were tilted in all sorts of directions. Newton believed that the distribution of cometary orbits was the state of nature, and that is how the planets would have moved had there not been an intervening hand. He believed that God established the initial conditions for the planets that made them all go around the sun in the same direction, in the same plane, and rotating in a compatible sense. Now, in fact, this is not a strong conclusion. And Newton, who was extraordinarily perceptive in so many areas, was clearly not here. The outline of a general solution of this problem was provided independently, as far as we can tell, by both Immanuel Kant and by Pierre-Simon, the Marquis de Laplace. Newton, Laplace, and Kant all lived after the invention of the telescope, and therefore after the discovery that Saturn has an exquisite ring system that goes around it, a flat plane of clearly fine particles. The first clear demonstration that it's made of many particles, that it isn't a solid sheet, was made by a Scottish physicist, James Clerk Maxwell. Upon a closer view of the rings of Saturn in the accompanying PDF, you can see an enormous sequence of such rings and a gap, the so-called Cassini division in the rings. We now know that there are many hundreds of these rings, all in a flat plane, and we now know, as both Kant and Laplace guessed, that they're made of tumbling boulders and dust particles. The rings of Saturn, by the way, are thinner compared to their lateral extent than is a piece of paper. Kant also knew about objects that were then called nebulae. It was not clear whether they were within our Milky Way or beyond. We now know, of course, most of them are beyond. Some of the nebulae were again flattened systems made, we now know, of stars. So Kant and Laplace, both of them explicitly mentioning the rings of Saturn, and Kant explicitly mentioning the elliptical nebulae, proposed that the solar system came from such a flattened disk, and that somehow the planets condensed out of the disk. But if that's the case, the disk, after all, has some rotation. Everything that condenses out of it will be going around in the same direction. And if you think about it for a moment, you will see that as the particles come together and make larger objects, they will have a common sense of rotation as well. What Kant and Laplace proposed is what we now call a solar nebula, or accretion disk, whose flattened form was the ancestor of the planets, and that it is perfectly easy to understand how it is that the planets are in the same plane with the same direction of revolution and the same sense of rotation. What is more, we now know that the random orientation of the comets is not primordial, and that very likely the comets began in the solar nebula, all going around the sun in the same sense, or ejected by gravitational interactions with the major planets, and then by the gravitational perturbations of passing stars had their orbits randomized. So Newton was wrong in both senses. A, in the sense of believing that the chaotic distribution of cometary orbits is what you would expect in a primordial system, and B, in assuming that there is no natural way in which the regularities of planetary motion could be understood without divine intervention